So now we need to talk about these physical properties called density and mass percent. And as I'm recording this, actually we've already covered this in lab, but let's take a look at it. So density, I like to say, is kind of how fluffy or how compact something is. And as I was getting ready to do that, looking over this morning, I was like, you know, we said earlier that all matter has mass and occupies space. Is that not cool? So all we're doing when we calculate the density of something is we take a something, that could be a cube of something, or it could be a gas, or it could be a liquid. What we do is isolate an object, and we take the mass of that object, we just weigh it, and we somehow get the volume of that object, and then we do a division problem. So that's density. So density, some people learn it as a capital D for representing density, but in physical science, what I learned it is the Greek letter rho. So for a rho, you kind of go like, I go like that for a rho. It looks like a P. That means density. So that's how we do it, and that's what it means. We talked, I know we talked about this idea that if I were to do a solid, liquid, and a gas, hopefully you would tell me that a gas over here has the most amount of kinetic energy. Those gas particles are just buzzing around. Here's in its solid state. They're actually, remember, stuck together with what we call intermolecular bonds. They're kind of vibrating, okay, but they have less motion. So right away, can you see where the density, I would call what? This is, put it this way, we are increasing density. Okay, we're increasing the density of something as you go from a gas to a liquid to a solid in general. Now, as it turns out, actually water does something funky, and I'll be talking about this. As you go from a liquid to a solid, water fluffs out. So water does something different. Actually, the density decreases with water. But if we just kind of talk about a liquid in general, let's keep it in its liquid state, okay? And I'm going to go ahead and cool it down. Does this make sense that as I cool it down, those particles have less and less motion, so they're actually going to become kind of tighter and tighter? So if I'm measuring the density of a liquid, okay, so density of a liquid, I'm going to take the mass of that liquid and I'm going to divide it by the volume. But the problem with that is as I'm cooling it down, the volume is getting less and less, and actually water will do that too. As I'm cooling it down, the density will decrease. So we kind of have a moving target here. What is the density of a liquid? Well, it depends upon the temperature of that liquid. Now, solids actually do a little bit of shrinking when they get cold and swelling when they get warm. Actually, this idea of solids expanding when they get warm is why when they make a concrete sidewalk, okay, this is my concrete sidewalk, what do? They put breaks in it. Why? So that concrete can expand and contract with temperatures. So solids do that, and gases are actually the worst. You think liquids kind of occupy a smaller volume as they cool down. Gases are even worse. So this is all to say that density does depend upon temperature. So density is a physical property. We say it's a physical property, remember, because we can measure, if density is a ratio of mass to volume, you can go ahead and measure the mass of something without a chemical reaction, measure the volume of something without a chemical reaction. That's clear. It's a physical property. Density actually is an intensive property. To remind you what that means it's independent of amount. A good example of that is if I had a cup, this is my cup of water, and if I had a bathtub full of water, and let's just say we'll make the water at 80 degrees Celsius. That's a little toasty, okay? If it's the same temperature, then no matter if I take this volume and get a ratio of the mass to volume, or this volume, okay, have more mass, but it's going to have that same ratio. It's going to have the same density of water at 80 degrees Celsius. One more thing I want to talk about in this part then is what are the units of density. And again, if you've already done the lab, you've kind of already bumped up against a couple of these units. Well, in order to understand the units of anything, especially if it's like a calculated thing, like density is a calculated thing, it's a calculated thing of mass to volume. What you need to do, and units are important in this class, units are important in physical science. What you got to do is look at what could the mass units be, question mark, and what could the volume units be. Now, when we do a division like this, it's important that we divide out the numbers part and we divide out the units part. So mass, up at mass, we could either, well, grams. It's just going to be grams. Now, when it comes times to volume, we could either have milliliters or we could add centimeters cubed. And actually, these two volumes, remember, they are equal. 1 milliliter is exactly equal to 1 centimeter cubed. So those are two great volumes. Now, if we go ahead and divide it out, then when we write it out, let me see, come down here. If you end up with grams over milliliters, we kind of write that grams slash ml. This is, okay, so that's what that means. Another way to write that is grams and ml to the -1 power. That's kind of how that goes. Now, if your volume was cubic centimeters, then your units are going to be grams over cubic centimeters, or grams per cubic centimeter, or grams times centimeters cubed raised to the -1st power. All negative first means that it's in the denominator.